Alright, for this problem, it's a review of when we were introduced to critical values in 6.1. And a critical value is a boundary with an area of alpha to its right. Right, and that's what it says here. The expression alpha denotes the z-score with an area of alpha to its right. Okay, so what that looks like is you have some area, we'll call that alpha in general, and the boundary, the z-score boundary, oops, I put the half on there, just alpha, is a critical value. So the answer to part A is to its right. So that was a multiple choice one. Okay, the next part, the expression z alpha half denotes the z-score with an area of, let's see, in this example we have, oh, I skipped this part right here. The confidence level 98% corresponds to a significance level of 0.02. So that's my alpha. Then z alpha half would be the z-score with an area of 0.02 divided by 2, because it's halved, so that would be 0.01, right? So that's alpha half is what the answer was for that. Confidence level, the area to the right of z alpha half is, as I said, 0.01, and z alpha half we can find that by looking in the table, the negative z-score table, and looking up an area of 0.01 and then working our way back out to the z-score values. Now you're going to get an answer that is z equals negative something, but by definition the critical value will have to be the positive version of that. Another way you could do this is by doing norm.inverse 0.0101. Okay, so that represents the area to the left, so it's still going to give you a negative z when you put in the area to the left, and then this would represent the mean of 0 for a standard distribution with z-score boundaries, and this would be the standard deviation, right? So the left area, the mean, and the standard deviation, or just put it this way, alpha half mu sigma. So when I do norm.inverse, what I got was negative 2.32, or I guess it'll round off to negative 2.33. Whether it comes from inverse norm or from the table, you'll get something similar. And then I want to make sure that even though the answer I'm getting is this side, the one that I want to use in my E formula is 2.33. And that is by definition the actual critical value, always the positive version.